Welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a square CFST column for its modal analysis. We will start by double-clicking on the modal module. We will first go to engineering data. Here we will create two materials. One is concrete M30 and the other one is steel. First, we'll give the property for concrete M30. The density is 2300 kg per meter cube. Next, we'll give the property of isotropic elasticity. Value of Young's modulus in megapascal is 25 and the Poisson's ratio is 0.18. Next material is steel, for which the value of density is 7850 kg per meter cube. Also, we will give the property of isotropic elasticity. Value of Young's modulus is 200 gigapascal, so it is 200 E9, and the value of Poisson's ratio is 0.3. Then we go to project and update project. Next, we will go to geometry and right click. New design modular geometry. I'll first go to units, millimeter, XY plane, look at. I'll go to sketching and choose the option of rectangle. I'll draw a rectangle, then I'll give it dimension. Since we are drawing a square, both these dimensions will be equal. So say it is 100 mm by 100 mm. Also, we will give the dimension between these two lines and these two, such that it is exactly at the center. So this will be 50 and this will also be 50. So this is a square section that we have drawn. We will go to modeling, extrude. We will select the sketch 1, apply, add material. The depth is say 2.5 meters, so 2500 mm, and generate. So this is the column. Again, I'll click on look at. We'll go to XY plane, create a new sketch, sketch 2, go to sketching and again use the rectangle option. I will select these 2 points for the inner rectangle. Now I want to draw a outer rectangle. So I'll give dimensions to this one. Now I'll give dimension to these two and to these two. So this one is say 120, B6 is 120 and these two are 60, half. So once this is done, we'll go to modeling, we'll go to extrude, select the sketch 2. Operation is add frozen, depth is 2500 mm and generate. Now you can see here this is the CFST column. The inner portion we will give as concrete and the outer one is steel. So we have two parts to bodies here. Now since we want to create two bodies separately, hence when I was doing the extrude 2, I gave the option of add frozen. If you give add material, these two will merge into each other and you will get only one solid. So it's of no use to me, hence I gave add frozen to create two different bodies. Now this solid is the inner one. I can rename this as concrete, such that when I'm giving the material assignment in modeling option, it will be easier. And I'll rename this as steel tube. So once this is done, we can close as the geometry is done. Next, we'll go to model and double click. We'll first go to geometry. This is the inner one, so I will give the material as concrete M30. For the outer one, the tube, I'm going to give the material as steel. Then I'll go to mesh and generate mesh. So I've created a coarse mesh. You can create a fine one. Since I'm using student version, a fine mesh will not be supported. Hence, I'm going for a coarse one. Then I'll go to Model, right click, Insert, Fix Support. At this bottom portion, I'm going to give Fix Support. So I'll first go to Face option and I'll select both of them and apply. Next, I'll go to Solution, right click, Solve. Now once this is done, I'll select here, right click, select all, right click, create mode shape results. I'll go to deformation and solve. You can see here there are 6 modes created for which we have 6 frequencies and 6 deformations. So we will go with the first one. Now we'll go to edges and select no wireframe such that these meshes disappear. Also, I don't want to see this banded contour. I want to have a smooth contour such that the colors blend into each other. So we will go to animation and see the first one. This is the mode of its vibration. You can see the frequency is 15.745 Hz. Maximum deformation is 5.264 mm. For the second one, you can see the deformation value is same, frequency is same, but the pattern of its motion is going to be different because this is a different mode altogether. This is the second natural frequency of the body. Then we go for the third one. Here the maximum deformation is 5.21 mm for a frequency of 95.644 Hz. You can see its pattern of motion. Then we go for the fourth one. The deformation is same as that of the third one and so is the value of frequency. So we will just check the pattern of its motion. Then we'll go for the fifth one. Here the frequency value is 249.43 Hz and the maximum deformation is 5.6781 mm. You can see its pattern of motion is different from the previous 4. Lastly, deformation 6 has a maximum deformation of 5.198. If you observe, all of them had this closed deformation, but for different frequencies. For the sixth one, the frequency is 250.39 Hz. Now, fifth and the sixth one frequency, again, they are very close. So, for the first 6 modes, now how did we get 6 of them? You can go to analysis settings. You can see here by default, max modes to find are 6. If you want, you can just click here and increase or decrease the number as per your requirement. So this is how you get 6 natural frequencies, the first higher order natural frequencies. Now what does this indicate? It indicates that these frequencies should not be tapped. If you tap this natural frequency of the column by any chance, there will be resonance and hence there will be more damage to the column. But this being a CFST column, that too of a square type, it will be much stable and you will have better control over the column. But these frequencies are definitely to be avoided. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.